potentially I'm going to have prostate cancer. Every man in this country, every man in the world is either going to die from prostate cancer or die with prostate cancer. The research we're funded for is the development of prostate cancer imaging agents. The plan is to develop an agent where we would inject it into a patient. It would go through the circulatory system, localize onto a prostate tumor, and allow us to image it from the outside using something like an X-ray. So what we've done is we've developed a chemical structure that binds specifically to a protein that's on the surface of prostate tumors, and that's a unique protein for these particular tumors. We've designed the compounds, these delivery vehicles, if you will, to be amenable to attaching different cargoes or payloads. So that cargo can be an imaging agent, that payload can be a drug, it could be a fluorescent dye that would allow surgeons to be able to image and visually detect a tumor while they're in an operating room. What's even more interesting is that once we have these agents bind to this protein on the surface outside of these cancer cells, this protein then internalizes into the cell, which allows us a mechanism for intracellular delivery of these imaging or therapeutic agents. Traditional technology may take 3 days or 4 days before sufficient amount of material or antibody has localized on the target site. We might be able to do what's called a 1-hour photo, right? We can do an injection and within 1 or 2 hours be able to take an image and have that diagnostic technique completed. So for the patient, there's an advantage of being able to make a single trip to a hospital. There currently exists no magic bullet for prostate cancer. In fact, there exists no magic bullet for many diseases. So we think that the technology that we're developing is going to provide a very highly efficient drug delivery or therapeutic delivery technology specifically for prostate cancer. And that the technology that we're developing, if it works, we can export it potentially to other diseases that are characterized by having unique proteins on the surface of these cells. And we'll start to try to expand this technique and this technology into breast cancer and potentially heart disease.